In the present video, we will discuss the JEE 2026 problem of properties of solids. Let's see the problem. The two wires A and B of equal cross section but of different materials are joined together. The ratio of Young's modulus of wire A and wire B is 20 by 11. When the joined wire is kept under certain tension, the elongations in the wires A and B are equal. If the length of wire A is 2.2 meter, then the length of the wire B is dash meter. So option A 1.1 meter, option B 2.22 meter, option C 1.21 meter, option D 4.44 meter. So first to write down the given data. So here it is given the two wires, that is wire A and wire B, and also mentions the equal cross section. So cross sectional area of the both of the wires is the same. So let's consider A suffix A is the cross sectional area of the wire A and A suffix B is the cross sectional area of the wire B. So here A suffix A equal to the A suffix B, and moreover here it is given the ratio of Young's modulus of wire A and wire B is 20 by 11. So let's consider E suffix A is the Young's modulus of the wire A and E suffix B is the Young's modulus of the wire B. So it is given that when the ratio of Young's modulus of wire A and wire B is 20 by 11. So EA divided by EB equal to the 20 by 11. And also given the when the joined wire is kept under certain tension. So here joined wire is under the certain tension, which means so force acting on the both of the wires is equal, then PA equal to the PB. And also given in the data, the elongations in the wire A and wire B are equal. Let's consider delta A is the elongation of the wire A, delta B is the elongation of the wire B. So delta A equal to the delta B. And also given the length of the wire A is 2.2 meter. Let's consider LA is the length of the wire A, which is equal to the 2.2 meter. Then we have to determine the length of the wire B. So let's consider LB. We have to determine the length of the wire B, LB. Let's see the solution. We know the elongation formula, delta equal to the PL by AE, where P equal to the tensile force and L is the length of the wire and A is the cross sectional area and E is the Young's modulus. So in the data it is given the elongations in the wires A and B are equal. So delta A equal to the delta B. Then we can be written as PA-LA divided by AA-EA equal to the PB-LB divided by AB-EB. And moreover, we have to observe in the data, two wires joined together, which means so PA equal to the PB, and moreover it is given the cross-sectional area of both wires is the same. So then AA equal to the AB. So then equation we can be rewrite as, so here, so PA equal to the PB, then so PA PB will cancel. Similarly AA equal to the AB. So similarly AA and AB will be cancelled. Then this equation will becomes the LA divided by EA equal to the LB divided by EB, and this is we can be written as EB into LA by EA equal to the LB. So we can be rewrite as the LB equal to the LA into EB by EA. So in the data it is given the EA by EB equal to the 20 by 11, then EB by EA will become the so 11 by 20. And also LA value also given, that is the 2.2 meter. Then substitute all these values. LB equal to the 2.2 into 11 by 20, which is equal to the 2.2 into 0.55. Then LB equal to the 1.21 meter. So option C is the correct answer. This is the solution, and thank you.